A live stream is good. Mickey, I'm going to make you the host.
Morning, everyone. For those of you who are, or I am this morning, we'll be starting soon. There's a lot of people joining, so we'll give some time for maybe 5 minutes for enough people to join, and as other people join, we'll catch along or follow along.
And if any of you have questions before we get started, feel free to go ahead and plop them in the Q&A channel or even chat. Any exciting articles you've read or even any outstanding questions, just let us know. And also, how was your weekend? Because over in the States, some folks are celebrating Mother's Day. Other people were just having a very relaxing weekend of going through the latest and greatest blog posts and courses on LLMs and NLP and Gen AI. So if you have any thoughts, questions, concerns, fears, go ahead and drop them in the chat and the Q&A.
Yeah, specifically if you have anything you want me to cover today, or is anything you're specifically here to learn, just throw it in the chat so I can make sure to get to it. Great. Nice. So yeah, there's a question about real-time aggregation I will touch on.
Also, other things you can drop in the Q&A or in the chat as well is let us know, for example, if you've had experience using a feature store before, where you had a company that developed it. Are you like a feature store newbie, or are you a veteran that is just trying to pick the right feature store? Feel free to also drop that in the chat as well.
Cool. Yeah, we can probably get started. the 8:05. We have a lot of people here. I'm sure there'll be more people joining. Where people, I think we're also live streaming on LinkedIn and Twitter as well, so. And then, there's a question, Shab, will this be recorded and shared?
Yes, we'll be recording this. It'll be available on YouTube, and I'll send out a follow-up email with a survey as well, because we love to improve these events. And I'll make sure to include a link to the recording.
Great. Nikita, you want to kick us off?
Yeah, absolutely. So, okay, let's get started. So welcome everyone to Feature Store's Buyer's Guide. Today we will be specifically talking about two key concepts. What is a feature store and what are the different kinds that exist? And the third most important one is how'd you pick the right one? Super important. So who do we have here today? First off, we have myself. I'm head of solutions for Featureform. You might know me from LinkedIn. I talk about stuff regarding MLOps, and I don't have a real picture of me on LinkedIn. So even if you met me in real life, you'd have a hard time recognizing me. The next person we have that I'm introducing is Simba, CEO of Featureform. So yeah, besides being our kind of product guru and mastermind of the Featureform direction, he's also created a number of different solutions prior to Featureform in streaming with embeddings. So all around an excellent person to talk about feature stores and also how they can fit into your existing infrastructure and platform and all the different needs around it. So yeah, so super excited. This is going to be a mostly conceptual, but also there might be some more concrete examples of what these feature stores look like.
Love it. Thanks, Mickey. That's a great intro. Maybe you could, or let me see, share my screen. Could you pass me host so I can share my screen?
You should be good to go.
Awesome. Thank you. Okay. Morning for me at least. So like Nikki said, today we'll be talking about feature. I'm sharing, yeah, Nikki.
Yep, crystal clear.
Awesome. So the goals today, there's a lot of them. This is kind of a goals / agenda. I want you all to leave the knowledge of how to talk about the metrics of MLOps. As you all probably know or have seen, budgets are shrinking, ML teams and MLOps teams are kind of under more scrutiny. So I also want to give you the tools to think about how to define the value of MLOps and how to measure that. So you can kind of continuously improve and also tie it to business value. We're going to do something I'm called a pyramid of metrics, which is something our amazing head of solutions, Mikiko, actually built, which will talk about the different types of metrics to use. We'll go into the components that make up an ML platform and a feature store. We'll talk about open source, proprietary, in-house, the case study that will show about Featureform versus Feast, for example. And then the final goal and the main goal of this whole talk is when you leave this talk, you'll be able to speak about how to evaluate a feature store. So we'll talk a bit about Featureform, but really I just want to give you a framework of how to even think about what a feature store is, how to evaluate them for your use cases, and how to kind of give you the framework to do that. So like I said, or like Mickey said, rather, I am Simba. I'm one of the creators of Featureform. Prior company, I ran a data science team building multimodal recommender systems. So all the stuff we're seeing now around embeddings, etc., we were kind of doing back in 2017. We actually built a full MLOps platform in-house because this is before the term MLOps really existed. And the most important thing we built we decided to eventually open source, and that is what became and is now feature form. So it kind of was actually born out of solving my own problem, solving my own need. So let's talk about the MLOps metrics. I think the dimensions to think about, there's three I like to think about. There's velocity, throughput, and risks. You can think of velocity as the velocity of an individual data scientist. So if I'm a data scientist in your company, on your team, how fast can I iterate? Data science is inherently a very iterative process. Think about in software engineering, my background, I've been both a data scientist and a software engineer. In software engineering, there's kind of typically a path, right? There's kind of a product roadmap, it might change, but it's usually pretty bad if it changes dramatically. So you can kind of constantly build in the right direction. With data science, we have a very long explanatory base. There's a lot of iteration. There's a lot of trying things out. In data science, if I'm a data scientist and I come to a meeting and I explain, hey, this thing, I tried it for a few months, I did all of this analysis and research, and I've come to the conclusion that we can't actually build a model that can do this. That would actually be totally fine, because they're very normal. In software engineering, that would usually be considered pretty bad if you burn a few months to figure that out. So data science is very iterative. So when I think of velocity, I think of how fast can a single data scientist iterate. Data science and ML also could benefit greatly through collaboration. A lot of teams can reuse learnings from each other, can reuse literal like features in this case or anything. The ability to share knowledge, information, artifacts, resources makes the team better as a whole. It builds this kind of repository that everyone can grow and build on and use, which makes everyone better. So that's throughput. It's really about collaboration. And finally, there are risks, and this depends a lot on the company. If you're doing a fun B2C app, like the risks you have exist, but they're probably lower than if you are, let's say, a multinational bank, in which case you think a lot about risks. So the goal of an MLOps platform is to increase velocity, increase throughput, and lower risk. So those are the kind of the main dimensions to think about. And it helps also think about again where you are. Like if you're a single data scientist or a small startup, I know someone mentioned being a small startup. The way you should think about this and what you actually need is going to be very different if you come from an organization where this was familiar. In these sorts of organizations, the value of collaboration, the value of risk management typically outweigh even velocity. Where smaller companies or smaller teams, you have 1 or 2 data scientists, collaboration is relatively simple. And what you think about is velocity. You still think about versioning and other things with regards to collaboration, but you don't have to worry about breaking silos. Regulatory risk depends again on what you're doing, but it's unlikely that you are going to be at the same level of scrutiny as again a large bank. At any point in time, by the way, in this talk, feel free to post any questions in the Q&A. So this is kind of the metrics pyramid. I think of it as there's 3 parts. There's the service and infra metrics. There's the product delivery metrics. I can sometimes call them platform metrics, and there's adoption metrics. At the bottom, the goal, you can think of them as infra metrics in the sense of these are questions like latency, how fast can I get features served, throughput, streaming, can I do streaming? This is the literally, can I do X? It's typically checkoffs. Can we achieve the latency we need? Can we, do streaming processing, etc. The middle piece is really where you get into the velocity, the collaboration, the actual value props of MLOps. And the final piece, and why this is a pyramid, by the way, is that at the bottom, if you can't serve features at the right level of latency to actually be usable, then who cares about the other two things, right? Like you can't use this. So you typically need to check off the service metrics before you can even get to the next level of metrics. The next level of metrics, like risk, volume, velocity, like these are the metrics that you think about when you try to value. We're going to go much deeper into this, but it's like how you value the MLOps platform. Is it making us better? How and how can we improve it? The final piece, and I think the most forgotten piece, is the adoption metrics. You can build this amazing platform that in theory reduces risk and makes data scientists better. But if no one uses it, or it's so hard to use, or so poorly documented, or whatever, you'll have low adoption metrics. And it doesn't matter what, like, it theoretically how good it is, because no one's using it. So these are the stages of metrics that I think about, and I'll kind of come back to these throughout the talk. These stages of metrics apply for the different modes you'll be in as a data scientist doing ML development. The first piece of ML development is the data piece. This is where feature stores live, and I'll get into that. But a lot of what we do as data scientists is taking data, transforming it, analyzing it, understanding it, building features, serving those features to models, and that's kind of one mode of ML development. Another mode of ML development is experimentation and training. So this is where we actually look at the model, like where we start hyperparameter tuning. We try different architecture, we try random forests, we try whatever else to try to in training, so on offline, achieve the results that we want from our model. Once we have features, we have a trained model, we need to actually deploy and serve that model in production. So that's another mode. Like, how do I get my model to production? And finally, when I have a model in production that's serving, I want to make sure it's doing well. When it does badly, I want to see why. So there's kind of this monitoring and evaluation piece, which is the final mode of the ML lifecycle. So as a data scientist, you'll kind of be jumping between these four, depending on what you're doing. But as you think about your MLOps platform, you should think about which part of these modes are you trying to help in. And you should also think about, as you're evaluating a feature store, for example, like, is that your biggest problem? Is your biggest problem, like, ask your data scientists, they know, like, how much time are they spending on the data? How much time are they spending in feature engineering? Are they having trouble there? Again, like, are they able to move quickly? So velocity. Are they able to collaborate? Throughput. Are they able, maybe like, are models failing in production? Do you have all this regulatory risk that you're worried about the feature side? If you look at those three metrics and apply it on top of this, you'll figure out which part of the MLOps platform you should be focusing on. And going into the question that someone had about, hey, I'm a small startup. If you're a large company, you have something for all of these modes. If you're a small startup, you likely will only have, like, you have to have all of these, but you might get by with maybe more like more simple scripts for things like deployment. Maybe you get by using the same monitoring tool you use for your typical software services for ML. So you should still figure out where your problem is. Typically, in my experience, the biggest problems are on either end. If you're a computer vision company, typically monitoring and evaluation typically is a bigger problem. With regards to like NLP companies or companies or a team doing NLP, a team doing fraud, a team doing working on tabular data, typically the feature engineering becomes the sharpest pain. So this is just a framework to use as you are deciding, again, to not, obviously the goal of this talk is evaluating the feature store, But I also want to even evaluate if you should be evaluating a feature store. Because if so, then if you should be evaluating a feature store and you could show why, then all this other stuff will be useful. Otherwise, you know, it might not matter, honestly. So on the bottom here, I mentioned the modes of the ML lifecycle. On the left, I've created these layers. And these are the levels of abstraction. Layers 0 and 1 are things like EC2, Kubernetes. These are kind of, they're not necessarily ML specific, we're just kind of the generic platforms that you build on. Even Colab kind of fits on layer 1. Layer 2 is the services. Services are things that actually, let's say, do the work. Like a training service is a black box that trains a model. A serving service is a black box for serving a model, so like Bento, for example. Monitoring service is a black box that collects logs, collects all that information. So like Y logs fits into there. A feature service is something that actually transforms and stores the features. So in our world, typically those two things look like Spark, Redis, etc. Those are the services layer. Above that is the workflow layer. In the workflow layer, you start to worry about collaboration, versioning, management, orchestration. So for feature orchestration and management, this is where you would define your feature versions, orchestrate their creation. This is, so if you just have the services, it's a data scientist's job to, for example, take a Spark job, run it on Databricks, copy the feature, materialize into Redis. And then with our training service, it would be their job to figure out and download the file from S3, that's a training file, put that into the model, etc. So the black boxes are required, because if you don't have them, then you can't orchestrate anything. But they put all of the effort of kind of the workflow on the data scientist. And typically what we see happen, which I'll get into, is a lot of bash scripts and just hacky things to try to make that work. The workflow layer, in my opinion, is the most critical piece of MLOps. Like having a workflow for features. How do I define features? How do I version them? How do I reuse them? How do I use them in production? Experimentation, where, hey, how do I define, it's like ML flow, like how do I define experiments? How do I define the hyperparameters I use? How do I keep track of trained models I've created? Like deployment, like model orchestration management, like, hey, what versions of the model are in production? I want to do a canary test. How do I do that? Those sorts of workflows are there. And finally, evaluation, which is I have these logs, but you might want to set up alarms. You might want to set up rules. All that stuff lives in evaluation. Finally, the platform layer. This is what the data scientists are interacting with platform layer. Now, that platform layer might be essentially non-existent, in which case they're interacting with the stuff underneath. But the platform layer is kind of the final abstraction you have, which makes all of this stuff work together cleanly and coherently. And this is typically where you see automation on things such as, you know, if I see feature drift in the evaluation, I'm going to retrain my model and then deploy it in the canary test. When you see that sort of stuff, that has to happen at the platform layer. That's the only place you can kind of talk between these different modes. In my experience, from my last company, 80% of the value of we built all of this stuff. So we had a solution for everything here. Almost all of the value came from the feature store. And like I said, I gave you the framework to think if that's true for your company. It is not true for everyone, but for many and most, it is the case that the data part of machine learning is simultaneously the most valuable piece. It's where most of the let's call it performance increases of your models are coming from. It's where your data scientists spend the most time. And it's the most repeatable thing you can continuously make better. It's almost always easier to come up with new signals to pull from the model than it is to try to come up with a new model architecture. So I talked about that pyramid, the inframetrics, product metrics, adoption metrics. So I want to talk about those and specifically in relation to feature stores. So these are the kind of questions that live in that layer. Can we process X terabytes of data? What is the latency for feature stores? How large feature tables can we materialize? For materialization, I need to copy my feature into Redis for low latency, essentially the cache. How much can we get into Redis? How long does that take? How fresh is it? What is the uptime of the feature store? Can we do last mile transformations, things like on-demand features? Can we do streaming transformations for things like just for streaming for those sorts of use cases? These are the questions that live on the metrics and infra stack for feature stores. Above that, there's kind of the platform metrics, the product metrics. These are things like, does the feature store support versioning? Can lineage be tracked? Can we do governance access control? Can we store and inform nearest neighbor on queries? Can we build point in time correct training sets? This is the part which is more about the workflow layer. So going back into like that services versus workflows, this is the workflow problem. This is the services problem. If you can't process your amount of data, who cares if the feature store has versioning? It's not useful because you can't actually process your data. Once you have Databricks, Redis in place, and maybe you solve all of this stuff, you need to see adding the feature store on top. Can you still check this stuff off? If so, then you can get to this next layer of, hey, can it do versioning? Can it do lineage? And then finally, and in my opinion, the most important piece, do your data scientists love the product? Do they use it by default? Like if they start a new project, will they bring in feature form? Do they interact with it every day? Understand if your data scientists don't want to use something, they don't like it, you're fighting a losing battle. Because in the end, if you're building an MLOps platform, that's your stakeholder. If your stakeholder doesn't want what you want to give them, no matter how much you can like theoretically talk about all this value, it doesn't matter. So we think a lot at Feature Form of how do we build a product that data scientists love to use. So I want to jump into feature stores and really talk about what feature stores are and the problems they solve. But maybe perhaps before I do that, I can leave a second for any questions that might exist so far. Oh yeah, I'll leave just a second for questions, if there are any. If not, then I'll continue on.
Hey Simba, do you want to take? We've got 4 in the Q&A. Do you want to take those now, or do you want to take them?
I'll take some of those later. Let me see which ones are maybe relevant now. Yeah, it's possible studies a feature form about setting up an offline online store. I'll come back to these because these aren't necessarily. I'm going to get to all these, but these aren't things I've talked about yet.
Yeah.
Cool. Okay, let's keep going. So what's a feature store? Well, let's talk about how data scientists build features today. You have data scientists on the left here. They're working in notebooks and maybe a set of scripts, like Python scripts, Bash scripts, etc. They're interacting with Spark, Snowflake, Redis to transform their features and put them in a place where they can be used to both train a model and to serve a model for inference. And again, there's so many different ways you can do that. If maybe you have a batch scoring model, which I think someone mentioned, like then maybe you don't need Redis, but you still need to have in a place where you can serve for inference. That could be out of S3, be out of Postgres. We've seen a lot of different stuff, but you still need to kind of think through that. So this is how data scientists work now. They are kind of almost manually interacting with Spark, Snowflake, etc. via their notebooks to build models. There's two sets of problems that we typically see, kind of going back to that again. I'm kind of saying the same point in a lot of different ways. There's this processing problem and the workflow problem. But with the processing problem, these are the inframetrics. The processing problems are things like, can it do streaming? Can I handle X amount of data? Can I serve a feature under 100 milliseconds of latency, under 10 milliseconds of latency? Those are processing problems. The other layer of problems are workflow problems. In my experience, people get really caught up in the processing problems. They think about things like, hey, we need to create features that have less than 500 milliseconds of freshness. We need to be that up to date. Or we need to be able to serve features in under 5 milliseconds. And in a lot of situations, those aren't actually the most pressing problems that kind of hit your data scientist. Typically, the problems that we see that are most painful are workflow problems, which are things like, how do we version things, manage things, share things, keep track of things? What happens if someone leaves a company? What happens if a new person joins a company? How do I handle all of the workflows and the process that exists in my ML team? And to show this, to illustrate this, think about this picture. If you've been a data scientist or you've worked with your data scientist, does this look familiar? Have you seen the DF final or DF7? Maybe if you have a more complex deployment, you've seen something like this. Like, hey, I have my features in production, but to get there, I interact with untitled 128, the IPy notebook. I have in that notebook, I have a data frame that's literally called data frame underscore final real. I have feature table v7 in Snowflake. I have bash scripts like copy feature to redis.shell that I run to try to get my features where I need them. I actually run transformations via some ad hoc YAML files and Spark submits. And documentation just doesn't exist. It's just entirely tribal knowledge. It's in my head. I know how I built it. I know how to build it. And that's all we have. This problem, I think a lot of people ignore it. And to an extent, like I said, you have to solve the processing problems before you can get to the workflow problems. But typically, once you have like Databricks and Redis or something like that, like Snowflake and Redis in place, you're solving most of the processing problem, except for, again, unique cases, maybe specific features in streaming, for example. But this is almost always, in my experience, higher priority. Can you solve this problem? So when you're thinking of evaluating feature stores, really think about what are the main problems we're having as a team. Are they processing problems? Are they workflow problems? And a way to see if it's a workflow problem is show this to your data scientist or this to your data scientist and see if they laugh. If they laugh, then they know what this means, which means they definitely have a workflow problem. There are 3 types of feature stores, all with the goal to solve both the processing and the workflow problem. We call them the literal feature store, the physical feature store, and the virtual feature store. Now, there's another kind of way we've seen them reference, which I'll mention here or I'll map here. So some people call a literal feature store just a feature store because it literally just stores features. Some people call a physical feature store a feature platform. And then we call the virtual feature store the feature orchestrator platform. So it's more focused on orchestration and storage, and not so much on processing. So I'll get into the differences here. So let's talk about this literal feature store. Sometimes it's called a feature store. This is what Databricks looks like. This is what Feast looks like. Now for Databricks and Databricks is feature store, SageMaker feature store, Feast. They don't do transformations. They only store the final feature value. So if you have a data source, you're transforming it with Spark. That version, that management and that like the orchestration happens separately from the actual feature store. So now it becomes your job as the MLOps person to build that unification. So it becomes your job to, hey, if I want to change a feature, I need to change the transformation. And so I have to go do that somewhere else, not in the feature store. I have to then write this new feature to a new feature table in the literal feature store in Feast or wherever. And I have to manage a version of it and make sure those things stay in sync and up to date. And that's really hard to do. Most of the problems that we saw and that we mentioned, like those workflow problems, like having Snowflake V7, having DF final, like those are problems on the transformation layer, in the feature and building the feature, not in storing the feature. So in our experience, the literal feature store is really makes sense if you think your data scientists know how to build and manage the feature transformations really well, and all they need is a specialized new database for the features. If that's your problem, then a literal feature store is something you should consider looking at. So that would be like a Feast, is a probably most common example. But Databricks' feature store and SageMaker's feature store look like this too. There's the physical feature store, sometimes called the feature platform. Someone mentioned Feather in the chat. Feather kind of falls into this. Tecton falls into this. Feature platforms do the transformations and the feature storage. So they do everything. Now to do this, so they try to solve the processing problems. They have their own stream processing engine or like kind of transformation engine that comes with it. The problem with that though is they typically come with their own custom DSL. Your data scientists have to learn and rewrite everything they've ever built, every feature they've ever built into this new language. And you're kind of stuck with it, like especially let's say a Tecton, where it's very expensive too and it's proprietary. All of the lock-in is huge. All of your code is now written in this new language that only works for Tecton. And if Tecton doubles or triples your price next year, which we've seen them do, you're kind of on the hook. Like you can't just change easily. The vendor lock-in is huge, and the adoption cost is huge because this is kind of replacing all those PySpark jobs you've written before, all the SQL you've written before. It's forcing you to unify all the transformations, use their transformation engine, and use their language. So if you think of Tecton and Feather, they are feature platforms or physical feature stores. And the problem you run into with them is high adoption costs and really high lock-in. And also the replacement. Like it's forcing you, if you have a problem with the domain language they have, like you can't do something that you need, but you know Spark can or Flink can, you're out of luck. It's kind of all you get. That's actually why we built the virtual feature store. The idea of the virtual feature store is that we will orchestrate your transformations on Spark, on Snowflake, wherever, Flink, on your sources. So all the data, the actual data, is transformed and stored on the same databases and data infrastructure you use today. And we are this layer on top of all of that, which provides feature versioning, feature management, feature search and discovery, a dashboard, feature monitoring, feature governance, and an API to serve features for both training and inference. So your data scientists are still working in SQL, they're still working in Jupyter, they're still working in Python. And they work via the feature form framework. We're kind of like a scaffolding. And you can plug in Spark, Redis, VBA, OpenAI's Transformer, Hugging Face Transformer. You can plug everything you need into this framework, and we will power them while again solving that workflow problem that your data scientists have. So we are a place, we're a repository for the features, and we also version the features. We also orchestrate the transformations. So we can schedule them, we can run them on Spark, we can handle errors, etc. So let me go for a specific case study. The two most popular open source feature stores are Featureform and Feast. They're the most widely used feature stores in open source. Actually, probably the most widely used ever, because I don't think the proprietary ones have as much, but it's hard to see that outside. But so Featureform and Feast are probably the two most popular feature stores. So let's use this metrics pyramid to compare them. So the inframetrics. So Featureform is 14.1 times faster than Feast on average for inferencers. So even though we both use Redis under the hood, Feast added so much latency that Featureform ended up being 14 times faster on average. Another problem, and this is an infra problem, is one thing that needs to happen in a feature store is you need to materialize your features from like your offline store, like Snowflake or Spark, into Redis. That materialization in Featureform has failover. So if the job fails, it will handle that, and it scales horizontally. Where with Feast, it runs in one process and has no failover. You have to kind of keep retrying it, which you've seen as a major issue. And the final inframetric to think about is the support for things like embeddings and vector databases and transformers, which Featureform comes with all of that inside or kind of integrated into the framework natively. This is obviously, I'm giving a talk at a conference this week, tomorrow actually, titled Feature Stores in the Post-GPT World. And as GPT continues to grow, obviously a lot of the main focus on traditional ML becomes true. But you kind of need your feature store to speak both languages to be valuable and continue to be valuable and worth the investment moving forward. For our product metrics, so Feast versus Featureform, Featureform rather manages and versions the feature transformations. So the actual logic that builds the feature, that lineage, is in Featureform, and it is not in Feast. Featureform has a dashboard to monitor feature quality, while Feast is pretty minimal. And this again, I'm using this case study as an example of a company that decided to use Featureform, and these are kind of things that they would think about. So the other is complex deployments, things like a lot of companies have both Spark and Snowflake. They have maybe their own SSO internally. All that stuff needs to kind of Featureform needs to play nicely with everything. And it's something with that feature orchestrator, that virtual feature store approach, it makes it possible to handle these really complex deployments. We have deployments where people have multiple different Spark clusters. And then finally, governance, access control, GDPR, HIPAA, all the requirements you would need to be able to do all of this is built into Featureform. Specifically, though, that would be Featureform Enterprise. So both the open source version of Featureform and Feast don't do governance, but Featureform Enterprise has governance, ACLs, GDPR, HIPAA support built in. And finally, the final thing to think about is product usage metrics. So look at any feature store you're considering. Someone mentioned Feather. Feather releases every 6 months. Feast releases every few months. Featureform releases every few weeks. We release multiple times a month, sometimes multiple times a week. And all of this shows, a lot of this is coming both from external contributors and ourselves being invested in continuously making the product better and investing in it. Another metric to look at and think about as you're deciding between feature stores is looking at the community. See how long it takes for requests to get answered. Like in Featureform, if you ask a question, our community will be answered in hours. In Feast, in our experience, it can take days, weeks. I just spoke to someone this morning who asked a question many weeks ago and it just never got answered. And now we're really deeply considering ripping feasts out completely and switching to a feature form. Just for the safety that kind of, hey, at least this company manages and supports this, and there's enough of a community here that I can feel safe using this and investing in this further. Finally, I mean, Mikiko mentioned a little bit about her background. Like, we have on our team a lot of people who come from a data science background, like myself, who are building this. So we think a lot about those adoption metrics. How do we build a feature store that is valuable? Things that we've released, for example, is like an experimentation API to make it easier to experiment, even when you're not putting your features in production, to just iterate on the features as you're experimenting. We have local mode, which is the ability to use feature form just locally without having to actually have it deployed anywhere, which can be useful for a data scientist that's just working on their laptop or just getting started with feature form. So these are all things to think about. Again, I just use Feast as an example here, but you can use the same thinking, like the same like stack, to compare feature form and any other feature store. And you can kind of come to your own conclusions based on that, and your own use cases. Everyone's different. What people need is different. Going a little deeper in feature form, I've been talking a lot about it abstractly. I thought it would be helpful for people who maybe have never used feature form or haven't used a feature store at all to look at how it looks like. So here's an example of a very simple deployment that's using this Postgres. Again, feature form supports Spark, supports Databricks, it supports Snowflake, it supports a lot of different transformation tools. You'd register your sources at the top here. You'd register your transformations. You'd register your features, your labels, your training sets. And for serving, it's really straightforward to say, hey, you know, I have this training set. I just want to loop through it in batches to train my model, or I need to get my user embedding feature for you know, this specific user. We also have on-demand features. Someone asked about this specifically, but we have the ability to have on-demand features, which are features that are literally just Python functions, and you're kind of storing that Python function in feature form, even though it's running kind of next to the model. So we would call these like last mile transformations. So if you need to do a last minute like transform, or you're doing an API call to OpenAI, all of that stuff can live in the on-demand feature. This is like the typical transformations are for pre-processing features. On-demand is for kind of the post-processing. And there's obviously like a dashboard we can dig into. I'll quickly go to open source versus enterprise. You can think of open source. I mean, this is going to be useful if you're a large company. If you're a large company, when you look at this, the main thing that you think about is risks. Like, it's just not a question. You can't get away with it. You can't hack it. It has to be done. You can think of enterprise feature form as a way to de-risk your investment in your ML. Both from the support side, like we help you, like our team helps, and also from the product side. It comes with a lot of parts of governance. Like, you can set rules and policies, like things like data scientists from marketing can't use features of financial tags. Data scientists must log in via SSO to see data sets. Models marked for automated loans can't use zip code. You know, even things like I need to delete all features for user X. All that stuff can be done in enterprise feature form. So if these are things that you think about or that are really important to you, enterprise feature form is something you should consider. Awesome, thank you. That was a lot of information to speed up at the end. I want to make sure I had time for questions. We do already have some questions which I'm going to answer. But if there's any more, I see a lot of them. So there are tons of questions I can go through. Okay, I'll start at the top. There is a question of, hey everyone, I'm a newbie in feature source from the sense I'm looking to integrate them, if at all needed, into our startup. I'm running batch predictions where feature engineering is quite large, and it is important to pre-process them. So feature form thinks a lot about the batch use case. Like I mentioned, that pre-processing, that versioning, that orchestration, all of those things that you're doing today, you can use feature form framework to do that. For the online store, you don't even need Redis. Like, we support a lot of like kind of call them like high latency stores, things like Postgres, which maybe are more they're cheaper. And if you're doing batch prediction, you might not care so much about having super low latency serving. In those cases, likely the problem you're trying to solve is one, the workflow. It's not like you don't know how to pre-process things now, but the workflow is so hacky and ad hoc that it's causing people to regenerate things constantly. Featureform would solve that. So in that use case, I think we are a viable option. And again, feel free for anyone who has more questions after this and want to talk. We're really easy to reach. I'm just simba@featureform.com. You can just send me an email directly. You can reach out on our site. We have Intercom. We have the Featureform community, which is a Slack channel, which you can also look at. Is it possible to start using Featureform without setting up any online or offline stores? Example, using on-demand features, goal to lower adoption barrier. Yeah, great question. So there's two ways to do this. One is you can literally just use on-demand features, which you should be able to do. I'm not actually, I'm not sure if you can just use like you should be able to, but I don't know if we actually would allow you to just register on-demand features. I've actually never tried it. Kind of interesting question, but try it. If it doesn't work, reach out to the community and we'd be happy to help you. The other option is local mode Featureform. If you're not using any infrastructure, you can define, manage, and serve the features on your laptop, and the features are defined in pandas or SQL. So it's pretty straightforward in that sense. Fever versus Featureform. I talked a lot about it. I mean, the main things with Fever is versus Featureform. With Fever, you're going to have to rewrite all of your features. You're going to have to the Fever product doesn't really have a company behind it. In the release cycle, their last release was in February, and the release before that was in late mid 2022. So they're releasing on 6 months on average. So that's something I would think deeply about too before you invest in something, making sure it's actually has a strong community as Featureform does. And obviously the physical versus the virtual, just as the products work, is also a big factor. Most people who choose Featureform over Fever, part of it is obviously the virtual feature store, but a lot of it is just literally, hey, you all respond, you're releasing quickly, you're building a lot faster. If we're it's an investment, we might as well invest in the fast moving product. How do you measure the data scientists really like the product? That must be tough to measure. Yeah, great question. So this is where I look at B2C metrics. Things like DAU over MAU. You can look at kind of how many data scientists do you have in the company that have access to Featureform or whatever. How many of them are actually using it actively? These are so it looks more like B2C metrics than traditional ML metrics. And the other piece, that's the quantitative. There's also the qualitative. Just ask them. Ask them to play around with it. Ask them to use it during your evaluation cycle. Ask them what they think. Because we've seen it happen before with some of our competitors, where companies will buy a competitor, and then they'll come to us after signing a contract because none of the data scientists want to use it, and they all despise it and push against it. So make sure data scientists are in the process too. Make sure you're getting their feedback. It will make your job easier in evaluation. And if you are having to go an enterprise product, it will make the case much stronger if your data scientists wanted to. Great, and feel free to keep throwing on follow-up questions. I'm just going through these. There's a lot of them. I want to make sure I get to them all. Some basic questions. How long will it take one person to set up a feature store? It depends on the feature store. With some of the more complex ones we've seen, it can take a while, honestly. Featureform, from our perspective, at this point, because I've done it so many times, I can get Featureform deployed from scratch in an hour or two. And that's for an enterprise deployment. That's for a big deployment, and that includes all the time for spinning up Kubernetes, spinning up Redis, spinning up Spark. But if you've never done it before, it could take a day up to a week. And feel free again, if you want to try feature form, you can join our community and ask for help. And we'd be happy to give some support as you run through that. Why would I want to dedicate a service for features alone? What value does that have opposed to versioning, tracking, and training databases? Yeah, so why not just have one thing that does both the feature store and the feature, you know, kind of, let's call it an end-to-end MLOps platform. There's a few of these that exist. Every one of them I can think of is proprietary. And they're pretty good. Most of them don't have feature store at all. So we don't actually do the data part anyway, so we don't have one. If we did have one, then it's typically like I guess in my experience, they're not as good because it's not best in class. If you're a small startup, you can try using some, if you have capital to go and invest and you're willing to kind of go all in on a like SMB style ML platform, it's definitely something worth evaluating. But thinking about if you're a fast growing startup, like will it scale and do our data scientists love it? It doesn't actually solve the problem, especially on the feature problem. We see a lot of people use ML platforms for everything and then just use the feature form with it, because the data part of machine learning is typically underserved by traditional MLOps platforms. These are really good questions. Hello, I work at a company where we have a nested structured data set, user exceptions, events, stored as a dictionary and pandas data frame. We construct all bunch of time series features, including embeddings and global averages. How well does FeatureForm support this kind of nested structured data sets? Yeah, great question. And then will we have to rewrite all this logic into some DSL, or can we reuse pandas logic? So the answer is actually the second question, which is FeatureForm allows you to use pandas directly, so you can reuse your pandas. What you're going to change is you're going to put that pandas code, each transformation, in a function, and you kind of annotate it. You say, you know, this is a transformation, and you can optionally give it a name, a description, a version, metadata, all that stuff can be added. But in a schedule, like how often should we run this? All that stuff gets added, but the actual transformation logic doesn't change, and that is uniquely a FeatureForm thing. That we don't have our own custom transformation DSL, and we use can we do a similar comparison between FeatureForm and Fever? How does FeatureForm differentiate itself from Fever apart from the community? The main difference between us and Fever is Fever has its own DSL. You have to rewrite all of your features in Fever. The other thing about Fever is all of Fever's transformations have to be streaming. So they only do streaming features. And as we all know, streaming features are much more complicated. Now, if you need them, we should use them. But in my experience, 90+% of features at a typical company are not streaming. And so forcing your data scientists to have to write streaming features, rewrite all of our logic, learn a new framework for defining transformations is a huge battle, and typically a losing battle. For a FeatureForm, we have streaming and we have batch, and for the batch, you're still writing pandas code or PySpark code or SQL. So you can reuse everything. You don't have to learn a whole new framework, and you get the full value of your current transformation engine. We're going to release some benchmarks soon, but my sense is that Fever is also much slower than FeatureForm because it has all this overhead, because it's taking its own language, it's compiling it, it's like running its own transformation engine that might not scale as well as like FeatureForms, because FeatureForm is just using Databricks or Spark or Snowflake or whatever you're using. So the idea is like this is a physical feature store versus a virtual feature store. So adoption costs, latency, lock-in, all that stuff becomes really important. We also have like a stronger dashboard and other things. If you want to go into deeper comparison, I'm happy to just reach out and we can do. We've done a few of these case studies. I'm literally doing one right now for a large bank, so I'm happy to answer that question. Are there any free tutorials, walkthroughs to try this offline with CSVs? Yeah, if you go to FeatureForm docs, so docs.featureform.com, There's a quick start and then in parentheses local. That would actually show you how to use the iris data set with pandas. For feature form. So I recommend that if you want to try out local mode with CSVs. It is compatible with pandas, that will actually use pandas in that example. And if you have any questions, please join the feature community, join it anyway, let us know what you think. If you like it, if you hate it, let us know and we can continuously make it better. With on-demand feature generation makes sense as the primary method of managing transformations if there is an already existing data source that can't be changed in the near term. So on-demand transformations are transformations that happen in the client post-processing. So it is a viable way to do transformations, especially if latency is not a problem. And if you don't care about having to rerun the code every time you serve the feature. But typically that's not the case. So it depends. You can do it. There are cases where it is possible and the right thing to do, but I wouldn't say it's common. But feel free to ask in the community and I can go more in depth. I know we're like a minute over time. I want to thank you all for joining. This has been a lot of fun for me. This is actually a new webinar that we gave, so this is the first time trying it. Let us know what you think. We'll be sending an email after with a link to our community and a question asking for feedback. If you want to talk more, you want to get a maybe a more in-depth demo, or you want to ask for specific questions like Fever versus feature form, please reach out. I can join on a call. I can have some people from my team who have literally done side-by-side comparisons for large companies, Fever and feature form, that can give you in-depth what they learned that they can share in those conversations. So thank you all again. Shab, am I missing anything? Anything else to share?
I think you got it all. We'll also include just links to the repo, links to the site, just so it's easy to navigate. And like I previously mentioned, we'll also include a recording of the webinar in case you guys want to review.
All right. Well, thank you all. Shab, I'm going to give you host just so I don't screw this up. Let's stop it. But thank you all for making time and hope this is useful. Let us know if it was, if it wasn't. Either way, all feedback is good feedback for us.
All right.